All right, so we got a lot of things to cover, some more fundamentals of Matlab in terms of function and operation, just to make sure that you guys understand some of the different variable types and all of those sorts of things. So in your workspace, you're going to want to present class, right click and include class. The reason I have you guys doing stuff in the scripts and not in command windows, we're going to cover that today. Some people will teach starting from the command window just because it's simpler. I want to actually see what I wrote and what's going on in the thing. So for this, I was doing some testing, so I'm just going to clear this out because I don't need any of it. So a couple commands that you want to include in all of your programs, very likely, are going to be, you want to use these carefully and intentionally. One is clear. What this does is it removes the variables from the workspace. So it's very helpful. This is the workspace. It just means that it cleans up the workspace in order to focus on whatever you are trying to do specifically, so that you don't have tons and tons of output, and you can keep monitoring what's stored and being stored as your programs grow in size, scope, and complexity. They don't need suppressed output because there's nothing to say. CLC is clearing the command window. Those two are going to be helpful for lots and lots and lots of things, so that you can keep track of what's being displayed and what's not. And you can start with whatever your new variable definition is. So you can start with, maybe I'll do capital A. I will assign to A, and let me see if I can make these bigger. I seem to recall, I recall that I can, yeah, I can at least zoom in on this part, and that'll help make it a little easier to see what we're doing in some of these. Yeah, it's something that I don't think you can do quite to the same degree in the other in the example, but I'll try and use this zoomed in version for our assignments, that as we're working, or at least some of our lessons, so that we have a pretty good idea what's going on. So give yourself as much space as you can in the script window. I like to be able to see what these are. You have to be careful about naming these things. So another couple fundamentals. So if we're going to go here to Matlab under documents, so here, what we're going to do, this is November 24 tests. You need to use underscores. Just do it. Don't ask questions. Just use underscores in the names. Also, when we go to write functions, we're going to do that using new scripts, and we're going to call that something that is going to be the name of the function. So we'll get there in a little bit, because this will at least help start defining a couple things. There's a lot of different variable types, and depending on what you put in, I'm going to do this first. I'm going to do this. Second, I'm going to do this. Third, I'm going to do this fourth, single quotes for strings. And what we're going to see is the workspace is going to fill up with, when we run this, there's also a couple variations, save and run, and some other things. Anyway, for now I can do either run section or just run. I'm going to run it. If you hit F5, it'll automatically save and run. So we have two different values. So these are stored as double precision, double precision, double precision, hello world. So all of these, even though 3 is essentially an integer, we can then reassign several variations of uint. There's 8, 16, 32, and 64-bit. Of A. We run that. We see that A gets updated to an unsigned 8-bit integer. We can also turn it into a character, like hello world. So it's a string, but then we can't do math on it. So if you were to try and do A times 3, it's going to tell you, what? So this doesn't really, even if we allow that output to show up in the command window, sometimes it will allow you to do character to integer multiplication. So here we have the equivalent of gibberish, because it can in fact multiply this, and it'll make the recommendation you might want to put a semicolon in so that you don't get 100 zillion things printing with the command window. But what we get here is gibberish because of how we've treated the data types of A. It's interesting to see what happens when these get printed out. So there's a lot of additional data types that we could use, but we're going to clear these and present these as an option. So A is this, and then ultimately, so it's printed as a character, and then it's converted back to a double precision integer at the end. So we can recover operations by redefining the data types. There's just some of these kinds of things that you want to be aware of. There's some other functions that you can make use of. You could say E is, and you could round C. There's a couple other variations of round. There's a couple other variations of round, but C would round to 13. Rounding down is one called floor. There's a bunch of these different kinds of functions. This rounds down. I think it's seal. Yeah, seal is round up. So floor is round down. Seal is round up. There's a number of other different things that are a number of other things that you can do. Rand is a random number. You could make it C by B. And yeah, they have to be integers. So you would have to do round, or nested functions. This becomes very much a thing in MATLAB speak. Round with a D, got to spell correctly. So then it creates a series of random numbers between 0 and 1 is its default. Rand and the array size that you have it to create. Rand does a lot of cool things. It's all predefined. So again, here's your comments in MATLAB speak are all these things. There's some suppressed things in here, but Rand will always start with the same base numbers unless you add it together. There's a couple examples. You can include so you can include some other functions in there. There's also a version of, there's a way to call rand integers by using rand-d and rand-n. Rand produces the same random numbers as if you had restarted MATLAB. So yeah, it mentions this because of reasons. So in order to generate actually 100% random numbers, you have to randomize it based on some other thing. Anyway, we'll get into probably some more of those details later. So some of these parameters are going to be really, really helpful for us to make things function in MATLAB, because we're going to do a lot of stepwise processing of data through a number of different aspects. So I'm going to change gears and we're going to look at a couple of other examples of some things here within MATLAB to better understand some of the functions that are available to us and how we can start using some of those, especially when we go to do some more complex things like input from the user and different ways that we can take that in, because you can now kind of develop programs and interfaces in MATLAB. It's pretty extensive. There's a lot of stuff that you can do. So we're going to pause for just a second. A couple other quick things I want to cover. When we're assigning variables, a lot of times in MATLAB, we're working with arrays and things that are larger groups of numbers, arrays and matrices. We want to be sure that we understand how to create arrays. So you can go by something like 1 to 5 and see what the output looks like here. 1 to 5. I'm going to take off. That was an inadvertent breakpoint. You enable those by clicking and then clicking and then stepping. It'll run up to a breakpoint and then stop. If I did, the middle number is going to be your beginning number and ending number are the beginning and ending of the array size. The step value, how much it changes each time, is here. So this would be how you create an odd array. All the way up to 100. The reason it recommends setting a semicolon is once you know it's working correctly, you can suppress the output and keep all this gibberish off your command window. You can do a couple of other things as well. You can add on a you can append there's a way to append this. I'm not going to worry about that right this instant because I'm going to work on some other concepts that'll be useful. We could do evens. We could do evens 0 to 100. There's a lot of different ways that we could do these things. But what if we wanted to, say we were taking data from something like a sensor like we've done, we want to store that information into a variable so that we can access it later. What would that look like? While loop condition, do these things. So we can look at what a while loop is, and we can look at some examples of what the syntax looks like. So a while expression has statements and then end, and then you can use a break statement to terminate the loop. So you could say while and then event greater than some value, while function greater than some value less than some value, basically until this condition is false, you run this. So you take E, add F to E, store it back to E, take F, manipulate it, N becomes N plus 1, that's your index. So it goes around and round and round and round and round again until it sees a break. So while one statements, while end pairs closes. You can also collapse them for ease of filtering through your code if you have really complex statements. This didn't used to be a feature. That's really nice. While, and then you create a. So we're going to comment that, and we're going to create a. And there's a couple ways to think about this. There's a couple different approaches to this. The way that you want to think about it is adding in a value. So a at some index value. Maybe it's n. And this becomes, if you wanted to just use this to build an array that was counting up, instead of printing it out every time, a is the previous value plus 1. So you could say while, in this case, you could say while n is less than 101, do this thing. And right now, this will throw an error. Simple increment. N equal n plus 1. Keep running until n is less than, while n is less than 101. Run this. This will get us to 100. But we're going to need to be able to define it because it's going to tell you, this looks like it's, maybe you want to pre-allocate this or do something. So if we try and run this right now, we get an error because we don't know what n is and we don't know what a is. Okay, n equals 0. So we fixed that. Now it doesn't understand a. What we can do is pre-allocate a by saying empty matrix. An empty array or empty matrix lets us store stuff. Is being pulled in. What else is it doing? And is indexing. That index won't make a difference because as long as it's got the key to the key pieces of the puzzle, it'll grow. So one of the things that we need to pay attention to, even if we pre-allocate an array, if we're going to be building an array, this is the language that we use to append an array, rather than spend lots of additional time troubleshooting, going back through. Anytime I get stuck on something that I'm trying to do, I go back to the Matlab help and I do something like, okay, bring up help on while, and grab this and go through and figure out, okay, what are they doing in the examples? If they're skipping over things, what are they doing with some of these? All right, so they're pulling stuff into arrays. Or I go and look at the browser help on a thing or whatever, and pull it up and then go find other functions, other pieces of the puzzle, and then find where I'm missing information. So that's a trick that I want you guys to start trying to pick up on the Matlab side of things. So in this format, it's taking A, adding to the end of A the value n. So when we run this, what we end up with is we have 0, 1, 2, 3, 100. So we can append the array. There's a couple other ways that we can break the while loop and all those sorts of things. So while n is less than 101, we get all the values 0 to 100. If we were to do this at 100, when we were to run this, we would only get to 99, because numbers start counting with 0, indexes start counting with 0. Even though we think of numbers as really starting with 1, they do actually start with 0. So indexing is an important aspect of how to do this, but this is a quick example of how to just append data to an array. Called A. So this is a very simple example of something that we can do in a lot of different areas. There's a lot of utility to being able to build something inside an array. It's not always going to be adding the index, sometimes going to be adding another value. There's a lot that we can do with this overall. So there's another example that I want to walk you guys through. So I'll clear this out and get it ready for another couple things that we want to cover as kind of some core competencies in using and practicing in Matlab. So another thing that makes sense at this point in time is to replace, or to take a look at what for loops do in Matlab. And the help gives us some sort of contextual clues to how these are used. So there's some kind of index that's used, and it's typically a range. So the syntax is going to be a lot like this, probably 90% of the time that you're going to use it. So for, and then n is 1 to 100. So for n is 1 to 100, for loops also need an end, just as a core bit of syntax. So we're going to say b is equal to a at n times we're going to say times random number. We're going to do random integer, rand. B n. We're going to create B. Still using the index. So 1 to 100. And we're going to plot these at the end so that you can see how we can take a look at things and start thinking in terms of functions and things. And that'll really be some of the next stuff that I think we'll get into, is the math and functions in MATLAB, how to perform our operations, plus minus. So add, subtract, multiply, divide, those are pretty straightforward. When we start doing matrix math, it's not quite as straightforward, but it's still important to understand. So we'll kind of get into some of that as well. So for n equals 1 to 100, we use Randy to give us an idea. I'm going to print out B at the end of this. Not enough input arguments for Randy. The integer max, so we can use this to pull up the help center. The integer max is really the minimum information needed, so we're going to say 5 as our max integer. So it's going to give us B. You could use 1 as your max integer. We'll use 5 just to give us some range here. So we know B is working. You got introduced briefly to the plotting options. We're going to plot B and A. I'm not going to play around with the options and things right this instant. We're just going to run this and take a look. There's a lot of cool and exciting things to be able to do with these, but it gives you a sense. So this is B on this axis. This is plot X and Y is how this is configured. So I'm going to switch this because there we go. So this is what I was thinking. Y is the tall axis and X is the short axis for the data, just to show what randomization is happening. But there is an overall linear progression because this is randomization based on what is essentially a y equals mx plus b slope. So we should expect to see this sort of value, and the numbers being larger allows for larger randomization of the numbers, so we can see what our data is actually doing. A lot of useful applications for that kind of data processing. There's a ton of stuff that we can do with some of this. So I'm going to change over to doing some math examples so that you can see some of what goes on in a couple of these processes. So I'm going to go ahead and get those ready real quick so that you can get a sense of what happens. I know they go over some of that in the on-ramp, or at least in some of the basics. I know for sure they go through some of that. So we'll touch on some of that as the next part of today. Another quick kind of fundamental is we've done a lot of operations where we've done something equivalent to math like this. We didn't really get into some of these parameters, but we can use the caret as exponents rather than having to use a power function and some other things. So you can use some of these tools that are more helpful. So you can also do operations. Square root is another thing that you can do using exponents and fractions, all of those sorts of things. This one will take this, take these two, and it'll follow PEMDAS so that the order of operations will be a specific way. So when we run these, we get our results. So 15, 2.5, 27, 2.19. So these are fairly straightforward. These are simple to understand. These last two are different in Matlab than they are in C, but what about 1 to 5 and F equals 5 to let's do by 5s to 30. I think those two will be the same size. So 1, 2, 3, 4, 5, 6. Nope, it's 5 to 25 because it includes the first number. So if we run that, all right, so we have 5 and 5. In arrays, if we try and do a simple multiplication, this is not going to work. And we'll see why. For matrix multiplication, you have to have the two inside numbers be the same size. The only way to kind of remedy this is to do a transpose of one of them in order to get the end result that we're looking for. And it'll give us a result. Rather than doing a for loop, it'll take the 1 times 5 plus 2 times 10 and so on, and it'll carry these through. There's an additional way where we can add a period that changes how we do things, and that allows for element wise 1 times 5, 2 times 10. So this is what I was just describing. 3 times 15, 4 times 20, and 5 times 25. So we can multiply the elements together in two parallel arrays. We just have to be very careful. You can't really do that the same way by doing an element wise and a transpose. That doesn't work. That's crossing the streams, and Ghostbusters would tell you that's really bad. So we don't want to do that. We want to do things a little bit more efficiently, especially when these get to be matrices. They need to be the same exact size, or they need to be something like a 2 by 1 multiplied by a 1 by 2, so the inside numbers have to be identical. So the column of one needs to match the number of rows of another, because of the way that the matrix math has to go. There's also matrix division, and so I'll show you a way that can get set up, because that seems super confusing, but actually can also be a super extremely valuable tool in terms of solving systems of equations to do matrix division. So it's really important to understand the way that math is done in this particular software so that we can understand how to set those up. So a couple more quick notes on this. Yes, we can also do transpose this way and get our results. It turns into a matrix. So there's a lot of different ways that we can do the matrix math. We're not really trying to teach you guys an entire linear algebra course in the same circumstance. So we're going to get into some of the examples. If you tried to just do division, it'll come up with some sort of an answer for you, but it that doesn't necessarily mean a whole lot. So you can actually do element-wise division as well. And it's going to show you 0.2, 0.2, 0.2, 0.2 for all of these, because that's not necessarily maybe what we're after. Maybe we actually want F element-wise divided by E, such that everything is 5 times itself. The other way is showing us that this is 1/5, i.e. 20% or 0.2 of its predecessor. So 1 times 5, 2 times 5, 3 times 4 times 5. All of these are showing us, in this case, the same data set. It's just a key. So the one that would really be interesting is if we were to throw the caret in there and do element wise for E to the F, and we would have it'll jump to scientific notation for what that end result looks like, because you'll have a very obscenely large number at the end. So you can go through and do any kind of mathematical operation. There we go. So E element wise to get to F gives you essentially the F vector back, or the it'll give you back that same up to 125 that we were looking at earlier. So a lot of different things that you can do with the data sets and the way that they work. So let's take a look next at some of the ways that we can start putting together equations. I'm going to see if I can find a description that will help you guys to visualize what the step leading up to setting this up for matrix division looks like, so that we can evaluate an example of a system of equations, put those into matrices, and sort of what all of that looks like and how it functions, because that's really where the true computational power of Matlab becomes immensely useful. To understand this, we're going to need a couple kind of pieces. Fundamentals for matrix math is the way that these work is you have essentially a format of A you have A X AX equal B. A times X equal B is the general form. We'll see this in the MATLAB help when we go to look for this in a little bit. This system of equations restated in matrix form is an A matrix of coefficients times an X matrix of really an X array of variables is equal to a B array of results. So 1 times A plus 2 times B plus 3 times C equals 9. 2 times A minus B plus C equals 8. 3A 0B minus C equal 3. So this is restated. These two are the same thing, but because this is why we have to have that transpose feature going on. If we have 1 by 3 and a 1 by 3, we have to transpose one of them to make it a 3 by 1 in order to multiply it, because this is how matrix multiplication works. Then in order to solve for this and get our variables and our answer, we have to do matrix division. That's where you jump back over here and you can look for, and you'll see there's a couple ways that we can go about it. Division by a singular matrix is the simple example that we're looking at here. No, that one's not actually the right result. So sometimes the Matlab help can be less helpful. You can do a remainder, you can do a right divide or a left divide. You can also do modulo, which is a remainder operation. So instead of mod is very similar to what it was in Arduino, and that part should be very similar. So we can do a couple of those things. In order to put that into MATLAB speak, we need to create a, and we're going to use these guys in order to do it. I'm going to do it all on a single line in order to make things make a little bit more sense. So 1, 2, 3, 2 minus 1, 1. Semicolons or colons to break up the, semicolons to break up the lines, because this tells it to go to the next line. So 1, 2, 3. What did I say? 2 minus 1, 1. Uh, 3, 0, 1. I'm going to suppress that output because I know it's entered correctly. X is an empty array. B blue lowercase to reduce the confusion. Nine, 8, 3. Each of these has one of those after them. All right. So, in simple terms, so I'll go ahead and print these two just so that you can see them. Operation. Okay, this looks like it should. This looks like it should. Make sure I've got my coefficients correct. -1 down here. -1. Important to have the correct coefficients because reasons. This, I'll show you what the results are. This says the matrix dimensions must agree. So this is, I think this one actually has to go B divided by A. If I remember correctly, let's see. B divided by A. So this is matrix divide. So the slash is supposed to use the same format. So we have another example given here. Yeah, it's result over it's because I need to do a transpose because reasons. So this is the correct format to write it in a mathematical format to make sense. Just for visualization's sake, but this will give you we got to transpose B means tipping it up on its side in order to get the division that we're looking for. So our A, B, and C values are X at 1, 2, and 3 here. So we can solve systems of equations with essentially a single keystroke once we've set them up. And this is really kind of the core of the power of Matlab, is being able to work on complex equational systems and allow us to be able to better understand the way that these functions and the way that these terms and principles can interact using all of these. So one of the assignments that I think you guys are doing is exactly this. It's taking a system of equations and using the power of Matlab to be able to solve this in a very simple, straightforward fashion. So this is the way that you go about doing it. It helps to physically write it down first and be able to actually see what's going on there. But this will at least give you guys a pretty clear start for some more key fundamentals and operations within Matlab. So I want to make sure you guys all get a chance to practice each and every one of these, because there's so much back and forth. So the normal in-class function would look like walking around and verifying that everybody is actually doing what they think they're doing here, so that we can make it all work and work correctly. So this will at least give you guys a reasonable starting point for kind of fundamental, simple MATLAB operations. So I'm going to pause this lesson here, and I think we'll pick up on another one to kind of start getting into some other features. There's much more extensive work that you can do for systems of differential equations and all sorts of things, because it still comes down to this with simple matrix division. So you can really simplify very hard problems down to digestible bite sizes. So we'll cut this here and pick up on some new ideas for the next one.